All right. Good morning, Logan. It's March. Let's see, what's today's date? March 19th, Thursday. Welcome to another class in your house. Um, so, regardless of what's going to happen for the next couple of weeks, I'm just going to make sure that you guys learn as much as you need to move on to that next level. All right. So, today's topic is section 9.1, solving quadratic equations by graphing. So, what this does is it's going to combine two ideas. It's going to combine the idea of solving quadratic equations, kind of like the one we had back in chapter, let's see, what chapter was that? Back in chapter 7, yeah? So something that kind of looks like this. So if we had x squared minus 5, let's change that to a 6. X squared minus 6x plus 5 equals to 0. You learned how to solve that type of problem, that type of polynomial, that type of quadratic by factoring. But then also in chapter 8, you also learned how to graph an equation that kind of looked like that. So what I'd like to do is I'd like to combine those two ideas and solve equations by just looking at their graphs. So the idea is that you have a very quick assignment, a very quick problem, nothing that takes too long. Okay, so here's our problem. We have x squared, x to the power of 2 minus 6x plus 5 is equal to 0. Oh, and I thought I also mentioned at this time, if you'd like to take notes, you can. You can also just take the video and use that as your supplement as you work out some of the problems that you're working on independently. So x to the power of 2 minus 6x plus 5 equals 0 is what we want to solve, and we want to solve it by graphing. And the reason we're going to solve by graphing is just so that we understand the relationship between the graph and the actual solution set that we come up with. Okay, so the first thing you're going to want to do is you're going to want to think of this problem not as equal to 0, but as equal to y. And you're going to start by finding the axis of symmetry. So we'll start off by writing down axis of symmetry. Now, as I'm writing this down, you may want to think back to what the axis of symmetry formula was. And the axis of symmetry formula just came out to x equals opposite of b. That's right, you heard me correctly. I said opposite of b. If you don't remember that, call someone up and be like, hey, isn't that what he said in class? Yeah, that's exactly what I said in class. The opposite of b over 2 times a, over 2 times a. Now, some things we need to take away from this problem. This number is c, so c is the number that has no variable being multiplied to it. B is the number that is being multiplied to the variable with just the x. And then a is the number that's being multiplied to the x to the power of 2, which happens to be 1 in this scenario here. So what we're going to do, and I wrote the 1 down, what we're going to do now is we're just going to take this information and plug it in. Notice that b is negative 6, so we have to take the opposite of that. So the opposite of negative 6 is just positive 6. So I'm going to write in positive 6 over 2 times. The next part to the problem is what is a, and a happens to be 1, so I'm going to write 2 times 1. So we have 6 over 2, because when you multiply 2 and 1, you get 2. And then 6 divided by 2 is just 3. So this right here is our axis of symmetry. So now if I wanted to start to graph this thing, I could. So I'll start my x-axis. Actually, that's a horrible x-axis. There are some tools here I can use. So what I'll do is I'll set up my x-axis, which kind of looks like this guy right here. So we have our x-axis. And then what I'll do next is I'll set up our y-axis. So we'll set up a y-axis. And then I just kind of want to graph this thing as accurately as possible. It doesn't have to be, perfect, but it should represent the equation that you're graphing here. So we have our axis of symmetry at 3. So I'm going to go 3 spaces to the right. So we go 1, 2, 3. And then I'm just going to draw that dotted line. Okay, so that it's not imaginary, it's just a dotted line. Right? And it's kind of our reflection line. So that means everything that happens to the left of it will also happen to the right of it. All right, next. After you find your axis of symmetry, the next thing you're going to want to do is you're going to want to find your vertex. So I'm going to start by writing down vertex. So remember, the vertex is the point that's on this line. Now, since it's on this line, and this line here is what we call 3, right? So this line is x equals 3. Since the vertex is actually on this line, since the vertex is actually on that line, and that line is x equals 3, we're going to take the 3 and plug it in to find where it's going to be as far as its height's concerned. Excuse me. All right, so I'm going to take the 3 and plug it in. So we have 3 to the power of 2, 3 to the power of 2, minus 6 times 3, plus 5. And that's just right here. All I'm doing is taking that x and turning it into 3. I'm taking that x and turning it into 3. And then I'm going to go through the order of operations. This would give me 9 minus 18 plus 5. And then 9 and 5, since they're both positive, I like to combine them. It gives me something a little bit easier to work with. I have 14 minus 18, which is equal to negative 4. I now have a vertex at 3, negative 4. Excuse me. All right, so now I'm going to graph that point, 3, negative 4. So now 3 is this way, and then I'm going to go 4 spaces down. 1, 2, 3, and 4. I'm going to put my dot right here. Okay, now here's where it gets a little tricky, or a little goofy, or a little sneaky, or mischievous. The idea is that we can take anything we've learned from previous chapters to graph. What that means for us is, since we understand the quadratic pattern to be 1, 3, 5, 7, 9, okay, the pattern is 1, 3, 5, 7, 9, all we need to do is use that pattern to find how this is going to graph. So what I'm going to do is underneath this axis of symmetry, I'm going to write 0, 1, 3, 5, 7. Now you're not going to actually write that on that, okay? You don't need to, but that's what I'm going to write down. Now what that tells me is it's giving me a little hint, and it's telling me, all right, so I'm going to go over 1, which means now I need to go this amount up. So I go over 1, and then I want to go up 1. Now, since that happened on the right, and this is the axis of symmetry, there's going to be another point that is on its mirror, on its reflection. Now I'm going to go over 1 more again, and the number I need to go up is 3. So now I'm going to go up 3 spaces. 1, 2, and 3. So there's my third point. Now I'll have another solution, another point that'll be reflected across the axis of symmetry located right here. Now for those of you that don't exactly get this, I'm going to do it one more time. I'm going to go over 1, and the number that corresponds to this movement to the right 1 is going to be 5 now. So now I'm going to go up 5. 1, 2, 3, 4, and 5. Now if I did it one more time, went over 1, I would go up 7. I kind of ran out of space there, so I'm not going to be going up 7. And then also remember, there's a reflection right here. Now if I take the points that I just graphed right there and connect them, so if I take these points, now sorry, my graphs are going to look real bad because I'm doing online math here, and I have less control. Okay, I have less control of my pen. What I end up getting is something that kind of looks like that. Now, if you recall, this kind of makes sense, that point right there, because of C. Where's C? C is right there. C is our y-intercept. I don't need you guys to actually find the y-intercept this time. That was just a helpful tool in the past. What I really want you guys to find are the x-intercepts, because that's the solution to this problem. So this equation right here, this equation has 2 solutions. And the reason I know it has 2 solutions, because the solutions are right there and right there. So my answers are 1 and, I gotta count, 1, 2, 3, 4, 5. My answers are x equals 1 and x equals 5. And this is how I solve by graphing. All right, now that you can solve any equation, any quadratic, by graphing, because all you have to do is find where they cross the x-axis, remember, find where it crosses the x-axis, you can now solve pretty much any problem I give you for the textbook. But there are some goofball problems out there that are really complicated to solve for. And that's what I want to explore. That's what I want to look into right now, is what are some of the special scenarios that can occur. So first thing we're going to do is I'm going to set up my x-axis and my y-axis. I'm going to have to do this a couple of times. So let's see, what do I want? I think I want one right here. We'll go right here, and then we'll do another one there, and then we'll do another one right there. All right, next, set up the y-axis for these guys here. All right, so now what I'd like to do is I'd like to explore, like, what are some things that can happen with your graphs, okay? So what can happen with our graphs? So we need to have an x-axis and y-axis so we can have this conversation. So that's what I'm doing. I'm setting up my possibilities, and there are 3 possibilities that can occur. The first one you just saw was when you had a parabola that kind of did something like this, okay? Well, how many times does this parabola cross the x-axis? 1, 2. That means you have 2 solutions, okay? So you would tell me what the 2 solutions are. In the last problem, your 2 solutions were x equals 1 and x equals 5. But then sometimes some goofy things happens like this, where it hits the graph only once. It hits at the vertex. Now when the vertex hits the x-axis, you only have 1 solution. You only have 1 solution. And then finally, this is something that can happen sometimes, is your parabola does something like this. and it says, you know what? Nah, I'm not going to touch the x-intercept. I'm not going to touch the x-axis. So what's going to happen here is we have 0 solutions because it doesn't cross the x-axis. Okay. All right. Thanks for hanging in there. Keep safe, everybody. I hope to see you guys as soon as we can. But until then, please keep 6 feet away from the people that are outside and try to stay home as much as possible. Hopefully you guys are taking care of your family and taking care of yourselves. Watch a bit of Netflix. I don't know, eat healthy. Definitely get some exercise. That's a big one there. Get some exercise. I know, coming from Rocco, the guy that doesn't like to do anything. But you should, walk around, do a stretch here and there, okay? All right, so I'll post this on Google Classroom, and I'll put the homework assignment. Remember, it's probably only going to be about 5 problems. So take your time with it, understand it, and text me or email me if you have any questions. All right, keep safe there, Logan.